Hello, this video will go over the final exam review for semester 2 of geometry. And this video is being recorded in 2021, but we may use this review multiple years, and so we may use this again in the future. All right, you can't retake your final exam, so please prepare so you are successful the first time. Do it once, do it right. And I'll give you a heads up that the exam, at least this year, is 27 questions long, and there are 27 questions on the review. And so expect each type of question from the review to be on the exam. It will not be the exact same numbers or the exact same problem, but be familiar with, okay, a problem like this will be on my exam. Okay, so make sure you know these problems and you can do them by yourself without any notes on your own, pulling from your mind. Okay, so here we go. It starts in the same order that we cover the content this year, and we start with Module 5. So number 1, lines that appear to be tangent are tangent. So this line right here is tangent, which means it touches the circle at exactly 1 point. Okay, and this we will assume to be a radius of the circle, and the tangent and the radius are perpendicular. We talked about that earlier. So that's useful to know. If I draw on the third side here, what I do get is a triangle, and not any triangle, but a right triangle. Okay, and I'm looking for the third angle, and I know two others, and so I can add 90 plus 65 and get 155, and then take 180 minus 155 and get 25 degrees is the remaining amount that I need to make the full triangle to be equal to 180 degrees. So the answer is 25 degrees. Number 2, find the measure of angle x. Well, this angle right here is 54 degrees. It's called an inscribed angle, okay, because it fits perfectly inside the circle. This is half of the arc, so I need to double 54 to find the measure of the arc. So 54 doubled is 108. That's the measure of this arc. Now this angle here is in the center of the circle. It's called a central angle, and it is actually the exact same as the arc, so it's also 108 degrees. Okay. Number 3, what is the name of the ratio or constant of proportionality between the arc length and the radius of a circle? And that is the radian measure of the angle. Okay, there are two ways to measure angles. There are degrees, which you're very comfortable with and familiar with. Okay, we just briefly defined radian measure this year as the ratio between the arc length and the radius of a circle. Okay, you'll talk a bit more about radian measure in Algebra 2 next year, but then really after Algebra 2, like pre-calculus or college math, college algebra or beyond, you only use radian measure of an angle as you move on in math. Okay, there are some properties about it that are convenient as you move on, but use radian measure in upper math and not degrees anymore. So we're just defining that at this level to be the ratio between the arc length and the radius of the circle. So in number 4, we actually do that. Let's first find the length of the arc. Now, I'm going to give you this formula on the test. Let me go to the very end of this review, and this reference sheet will be given to you on the semester exam. Okay, one of those is the length of an arc. Okay, that's given to you on the exam, so if you look for it, it's going to be there. Okay, and that equation was x over 360 times 2 pi r. Well, I'm just going to plug stuff in. X is the central angle measure, or the arc length. They're the exact same. So 45 degrees, or 45 is x, and r is the radius of the circle. So plugging stuff in, I have 45 over 360 times 2 pi times 14. Now, let's remind you, I know it's a while since we've done this, let's remind you what it means to be in terms of pi. In terms of pi means I will not multiply by pi when I compute this, and I get 3.5 pi. So I multiplied 45 over 360 times 2 times 14. And that's 3.5. And 3.5 times pi is an exact answer. Okay, that's not what most people want to know. If they want to know how long is this curved part of something. But mathematicians prefer exact answers. And so preparing you for upper level math classes, you should be prepared to give an exact answer or an estimate from your calculator. This is asking for an exact answer in terms of pi. Okay. Also, don't forget your units. Okay, now back to our conversation about the radian measure. Okay, again, it's the ratio between the arc length, 3.5 pi is the arc length, divided by the radius, 14. Okay, now 3.5 over 14, you may not recognize that, but 3.5 is half of 7, and 7 is half of 14, so this actually is pi fourths radians. Okay, 45 degrees in radians is pi fourths radians. Okay, and you'll look at that a whole lot more in Algebra 2. In number 5, we want to find the area of the sector. Okay, again, that formula is also given to you on that reference page that'll be given to you on the exam. And that equation is x over 360 times pi r squared, the fraction of the circle that I want times the area of the circle. Okay, 75 degrees is x, and 9 is r, and so I plug those in. 75 over 360 times pi times 9 squared. This one does not say in terms of pi, and so I would take it in either way. So if I don't specify in the problem, then you can give it to me either way. This is equal to 16.875 pi inches squared. The units are squared, not the number. Or the estimate would be it's approximately 53.01 inches squared. Either one would be a fine answer for me. Okay. All right. Moving along. Number 6, the equation x squared plus y squared plus 14x minus 12y is equal to negative 4. Defines a circle in the xy coordinate plane. What is the center and radius of the circle? Well, I need to complete the square. And the first thing I'll do is to reorder these terms. I want the x squared term, and then the x term, and then leave a space. And then the y squared term and the y term, and leave a space, equals negative 4. Okay, and then I need to complete the square for both x and y. I want this to be a perfect square trinomial, and the one it will be is the same variable x, and then half of 14 is positive 7 squared. That's what it has to be. Okay, so I took half of 14, positive 14, and in order to get that, I will need the number here to be 7 squared. And 7 squared is plus 49. But to keep this equal, if I add 49 to the left, I must add 49 to the right as well. Okay, so that's the process for this. I will do half square balance. Half of 14, 7 squared, and then balance by also adding 49 to the other side as well. Let's see that again for y. So I have y here. Half of negative 12 is negative 6. Negative 6 squared is negative 6 times negative 6, which is a positive 36. And then to balance, I'll put plus 36 on this side as well. Now, negative 4 plus 49 plus 36 is 81. Okay, now it kind of just happens that what I get is an equation in standard form. And the value of that is that I can now kind of read off from this equation what the center and radius are going to be. Okay, and the center is, you switch the signs, a negative 7, make that a little clearer for you, negative 7 comma positive 6. You switch the signs for the center, and then the radius is the square root of this number 81, and the square root of 81 is the number 9. That's the center of the radius of this circle. What is the equation of the circle with center -1, 6 that passes through the point -5, 4? Well, let's start with a center of -1, 6. Again, there's a switching of the signs that happens with the center of a circle, so I get x plus 1 squared plus y minus 6 squared is equal to r squared. I don't know what the radius is going to be, but I do know it goes through the point -5, 4. So I will plug -5 in for x and 4 in for y, and I'll see what r squared value I need to have. So plugging those in, I get -5 plus 1 squared. And you don't change the sign when plugging the numbers in. Just the center is where you change the signs. 4 minus 6 squared is equal to r squared. Okay, so -5 plus 1 is -4. And 4 minus 6 is -2 squared. I'm running out of room. -4 squared is -4 times -4, which is a positive 16. -2 squared is -2 times -2, which is 4. And so I get 20 is equal to r squared. Okay, so I plug this value in here, bing, in this very first equation, and that's my equation. Okay, so here it goes. It is x plus 1 squared, y minus 6 squared is equal to 20. Okay? All right. Number 8, lines that appear to be tangent are tangent. So that means that this line right here is tangent. Okay? And this is a radius, and so this is a right angle. This is also tangent and a radius. This is also a right angle. And this shape right here is a quadrilateral, and we've learned that quadrilaterals have angles that add to be 360 because I could triangulate and get two triangles. Now I don't need that in this problem, but I will get two triangles, so I get 360 degrees. So I know what three of them are. Minus 90, minus 90, minus 120 is 60 degrees. Okay, so this angle is 60 degrees. Now, this happens sometimes in mathematics where a pattern that looks like it might be there is like a specific case. So the fact that 60 is half of 120 was just a coincidence. What it really boils down to, using this two right angles method, is that this angle Q and this angle 120 will actually add to be 180. That's the piece that actually will always be true. So if this was instead 100, this would be 80. It's not a half relationship. It's their supplements of each other. They're supplementary. Okay, number 9, what is the equation of the circle with center -3, 1 and radius 7 units? Well, it's like the ones we did earlier, but this is just giving us a center and the radius. Again, with the center, you switch the signs, x plus 3 squared plus y minus 1 squared, and then what's over here is the radius squared. So 7 squared is 49, and I'm done. There's not a whole lot to that one if you know how to take the center and the radius and make the equation of the circle. Okay, in number 10, which of the following must be right angles? Well, ABC intercepts a semicircle. And so this is 90 degrees. And the theorem is called Thales Theorem. Or say that the intercepted arc intercepts a semicircle. Okay. ABD, let's see here. Sorry, ABE is not. okay, because that intercepts less than a semicircle. BCD also intercepts less than a semicircle. This one is also not. And EBD is the radius and the tangent. So this is a radius is perpendicular to a tangent line. So that is also a right angle. Number 11, use coordinates to prove or disprove that the point 1 root 3 lies on the circle centered at 0, 0 and containing the point 1, 2. Well, if the circle is centered at 0, 0, then it'll be x minus 0, y minus 0 squared equals r squared. I switched the signs, although it's 0, so it doesn't really matter in this problem, but just out of habit, I'll get used to switching those signs. Okay, and I know this circle contains the point 1, 2. So I'll plug 1 and 2 in. I will not change these signs. It's only the center where you change the sign. 1 minus 0 squared plus 2 minus 0 squared is equal to r squared. 1 minus 0 is 0. Sorry, 1 minus 0 is 1. 1 squared is 1. 2 minus 0 is 2. 2 squared is 4. And so I get 5 is equal to r squared. So plugging that back in, I get x minus 0 squared plus y minus 0 squared is equal to 5. Okay, that is a circle centered at 0, 0 and contains the point 1, 2. Now the question right now is the point 1 root 3 on that circle? Well, if I plug 1 into x and root 3 in for y, I get 1 minus 0 squared plus root 3 minus 0 squared. Does that equal 5? I'm not sure. 1 minus 0 is 1 squared. Root 3 minus 0 is root 3 squared. Does that equal 5? Still not sure. 1 squared is 1. Root 3 squared is 3 because root 3 is the number that if I squared it, I'd get 3. So if I square that number, I get 3. Is 1 plus 3 equal to 5? Well, no, it's not. So no, 1 root 3 is not on the circle. Okay, number 12. I'm now on module 4. Okay, find the equation of the line parallel. Let me actually get these two kind of on the same page. Let me scroll up a little bit. Find the equation of the line parallel to y is equal to 2/3 x minus 2 that passes through the point 3, negative 1. Well, if it's parallel, it'll have the same slope. The slope will be the coefficient of x, or 2/3. So my equation, my answer is y is equal to 2/3 x plus some y-intercept. I don't care about the minus 2. It is not going to have the same, well, it probably won't have the same y-intercept. Okay, but using the point 3, negative 1, I could find what my y-intercept would have to be. I would plug 3 in to x and negative 1 into y. Those lines kind of got crossed there, but hopefully you can follow. Negative 1 is equal to 2/3 x, but x is 3, plus b. Kind of go up here so I have more space. I get negative 1 is equal to 2/3 times 3 is 2. Okay, you can see that by multiplying fractions, or if you have, anyway, 2/3 of 3 is 2, plus b. Now if I solve this for b, I will subtract 2 from both sides, and I get negative 3 is equal to b. So plugging that back into our first equation, I get y is equal to 2/3 x minus 3. Okay, will be parallel to this equation because it has the same slope, but it's true at 3, negative 1, and so it passes through that point. Number 13 is very similar to it, except that it's perpendicular. And if it's perpendicular, then the slope of my line, the answer, will be the negative reciprocal of -2. The negative reciprocal. So I flip it over from -2/1 to a -1/2 and change the sign. It's a negative reciprocal, okay? Most students have down, they flip it over, but the changing the sign for some reason isn't always there. So +1/2 is what I want in this problem. So y is equal to 1/2 x plus some b value, okay? It is very similar to number 12. I now need to find the correct y-intercept. So I will plug in 4 in for x and 7 in for y. And I get 7 is equal to 1/2 4 plus b. Okay, me again gets more space. So I have 7 is equal to half of 4 is 2 plus b. If I subtract 2 from both sides, then 5 is equal to b. So plugging that back in the original equation, not the original, but this 1/2 x equation, you get 1/2 x plus 5. Okay. Cruising along. Number 14, find the slopes of the four sides, then prove or disprove that this figure is a rectangle. Well, the defining characteristic of a rectangle is that the four angles are right angles. And the way you can tell if things are right angles on the coordinate plane is if their slopes are negative reciprocals. So I will find the slopes of the four sides. And I'll start with AB because that kind of goes in that order. This line right here has a rise. Let's see here. I will run and I'll rise. So I'll rise 1, 2, 3, 4, 5, 6. I rise 6 and I run 2. And notice that I'm going up. If I go left to right, I'm going up, or I'm going positive x and then positive y. So this is a positive number. 6/2 is 3/1. Okay. That's the first one. I'll just keep walking my way around. BC, this line right here, I'll kind of go down. That's a -1. And then I'll run a +3. So this slope is -1/3. I'll kind of pause for a second here and look and compare 3/1 and -1/3. Okay, are those negative reciprocals? Are they, if I flip one over and change the sign, do I get the other one? The answer is yes, we do. Okay, let's keep this kind of multicolored. So CD, this right here, I will run a +2 and I'll rise a +1, 2, 3, 4, 5, 6. This slope is again a 6/2. I'm going positive, or overall I'm going up as I go left to right. And I get again a 3/1. Okay, so again I'll compare this slope, 3/1, with this slope here, -1/3, and those are again negative reciprocals. So far I have, I'm not sure what angle color to use, a right angle here, a right angle here. So it's looking pretty positive. I mean, it's looking like it's going to be a rectangle because I have some right angles. But I'm going to finish and find all of them. So this side, AD, has a slope. Let's see here. If I go down -1 and I run +3, that slope is -1/3. Again, that is a negative reciprocal with both this 1/3 and this 1/3. So the two adjacent sides. And so this is a right angle and this is a right angle. So it must be a rectangle because the adjacent sides all have slopes that are negative reciprocals. I won't write that out. I should write this out in words, but due to the fact of the time in this video, I'm not going to write out word for word. But basically, it has to do with the adjacent sides have slopes that are negative reciprocals. Number 15, find the area of the following triangle. The way I'll find the area is by sticking this triangle within a very tight rectangle that fits along our grid. You don't want any extra space. I want to go right and hit all the vertices that I can. There's my rectangle. Okay. Now, what is the area of this rectangle? Well, it's 1, 2, 3, 4, 5, 6. The area of the rectangle is base times height. which is 6 times 1, 2, 3, 4, 5, 6, 7, 8. 6 times 8 is 48. 48 units is the area of this rectangle. Now, there's some negative space that I don't really want. There's this space right here. There's this space right here, and there's this space right here. So I will find the areas of the negative space and subtract them. Okay, this one right here, now these are all triangles, and triangles have an area of 1/2 base times height. The base is 2, and the height is 8. So half of 2 times 8 is going to be 8. So this area here is 8. Also, I'll take that away. This green negative space, again, it's a triangle, 1/2 base times height. The base is 1, 2, 3, 4. And the height is 1, 2, 3, 4, 5. Okay, half of 4 is 2 times 5 is 10. And so this area here is 10. Last but not least, this blue negative space, I have 1/2 base times height. The base is 1, 2, 3, 4, 5, 6. And the height is 3. Half of 6 is 3. 3 times 3 is 9. So I'll keep my color coordination. The overall, let me go over here. The overall, I have 48, and I will subtract 8, and I will subtract 10, and I will subtract the 9. Okay, so grabbing a calculator. 48 minus 8 minus 10 minus 9 is 21 square units. That is the area of the triangle that's left, triangle ABC. 16, in the xy coordinate plane, the coordinates of L are -7, 4. This is L. And the coordinates of point M are 5, 0. Point P lies on segment LM, so P is somewhere on this segment, so that the ratio of the distance from L to point P to the distance from point P to point M is a 2-to-1 ratio. So just a ballpark of where it might be, probably somewhere like in this region. Okay, so it's a kind of a 2-to-1 ratio. Okay, what are the coordinates of point P? Well, I'm going to think about this in the x direction and the y direction separately. Okay, I will first look along the x direction. In the x direction, I'm starting somewhere, and I'm going some ratio of the full length. Okay, I'm starting at L because it says from L to M, and then L to P, and then P to M. So I'm starting at L. I'm starting at an x coordinate of -7. Okay, and then 2 plus 1 is a total of 3 parts. So I'm going 2/3 of the way along this path, and the length of the path is my ending of 5 minus my beginning of -7. So I have -7 plus 2/3 of 5 minus -7 is 12. So I travel 12 in the positive direction. And 2/3 of 12 is 8. So I have -7 plus 8 is 1. So it looks like I was off by just a little bit. So it's actually more like here. This point is my answer right here. So I have the x-coordinate pretty easy. I now got to find the y-coordinate. The y-coordinate is very similar. I start somewhere, and I go the same ratio of the y length, y sub 2 minus y sub 1. Okay, y sub 1 is the y coordinate of L. It's 4. I will go the same ratio 2/3 of the way along the full distance, and I'm going to end at 0 and start at 4. So if you kind of follow this equation, it'll deal with the signs for you. Okay, because 0 minus 4 is negative, and so I'm going down, and I get that from the equation. So 4 plus 2/3 of -4. 2/3 of -4 is, let's see here, -8/3. And so we get, anyway, 4 plus that, you get you get a positive. Positive 4/3. And so you can either give the answer of 1 comma 4 thirds, or if you're more of a decimal kind of person, you get 1.3 repeating. Okay? And either one of those would be the correct answer for that point that is the ratio of a 2-to-1 ratio. Number 17, find the coordinates of point P without using any new variables. Well, I want to find this coordinate here. The x-coordinate is pretty easy. It's the same one as this one, right? So I went over A to get to B, sorry, to get to this point. I go over the same amount A to get to P, so this x-coordinate is A. That's not too hard. The y-coordinate, though, it's not as easy because I look over here for a good y-coordinate and there's nothing. I got nothing for my y-coordinate. So I gotta look at what y-coordinates I have. So C goes up this high, right? That's too high. I've gone too high. Now, how much too high did I go? I went this length of A too high, right? So if I go to C and I subtract A, I'll go, up C, but then I'll go down A, which will put me right at P. And so this, whoops, I made a mistake. I'm sorry. This is B. I go down B. So this length right here is B. So I go up C and then I go down B. And this is my coordinates of point P without using any new variables. All right, we made it to module 3. Give an informal argument for the formula for the circumference of a circle based on the definition of pi. Pi is defined as the ratio between the circumference and the diameter of a circle. In other words, the number of diameters that I need to fit around the outside of a circle. Okay? And I'll use that definition to give a reason for the circumference formula for a circle. I'll multiply both sides by the diameter, and I get circumference is equal to pi times diameter. Okay? Now, based on the question, you could just stop there. Okay? I'm going to keep going because there's 2 different answers you can give for the equation. That's one of them. Now, using the fact that the diameter is twice the length of the radius, you could also get pi times 2r, rearranging from simplest to more complicated to pi r. This is the other one. Okay? So you can get either one from the definition of pi. In number 19, the figure shows a plane slicing through a cone. The plane is neither parallel nor perpendicular to the base of the cone, and the plane does not intersect the base of the cone. What is the shape of this section? Well, if you cut a cone not parallel to the base, what you actually get is an ellipse. Is it 2 L's or 1? I always doubt myself. Okay, you get an ellipse. Number 20, give an informal argument for the formula for the area of a circle using the following diagram. Okay, so we're going to derive the area of a circle from this diagram. We start off with the circumference, which we derived just a second ago as 2 pi r. Now, we saw an applet, or a thing that kind of stretched it out and then took it in half. So this length here is just the white, this white length here, which is half of the circumference, which is 2 pi r. No, it's not, sorry. Half of 2 pi r is just pi r. And then this height here is the same as the radius. So this looks kind of like a parallelogram. And the more sectors you cut, the more it'll look like a parallelogram. And so you get base times height. The base is pi r, and the height is r. So the total area of this circle is pi times r squared, which you probably already knew. But this is how it was derived, or where it came from. Chapter 21, a map of Mountain View neighborhood is shown. The population of Mountain View neighborhood is 282 people. The length of each block is the same, and the length of 10 blocks is 1 mile. Okay, that does not mean that this is 1/10 of a mile. That's an area. I'm looking for a length. The length, so 1, 2, 3, 4. If I had 10 of these, it'd be a mile. But I only have 4. How much? 4/10 of a mile. Okay? And this height here, let's see here, I have 3/10 of a mile. So what is the area of this neighborhood? Well, I have 4/10 times 3/10, and so I get 12/100ths. Okay. Each of these, by the way, is 100th of a mile, of a square mile. Okay, because scale factors. Anyway, we won't go there. It's 100th of a square mile. So that's the area of Mountain View neighborhood. Okay, the population density is people over the area. The people is 282, and the area is this 12 over 100, which, just for easy math, 0.12. Okay, now 0.12 is a very small number, so as I divide by a very small number, less than 1, this number will get bigger, and it gets to be, I'll do it down here, 2350 people per mile squared. Okay, so if I had Mountain View neighborhood duplicated, enough times to fill up an entire square mile, then I could fit 2,350 people, living in that neighborhood. Number 22, an aquarium tank is in the shape of a rectangular prism with the dimensions labeled. A cylinder with a diameter of 6 inches and a height of 8 inches is used to fill up the aquarium. Okay, so I have an aquarium here that is 24 by 12 at its base. So the area of the base is 24 times 12, which is 288 square inches. And then the volume of this aquarium is the base, which is 288 times the height of 24 inches. So 288 times 24 is 6,912 inches cubed. Okay, so that is the volume of the aquarium. Now, the volume of the cup that I'm using is it's a cylinder, pi r squared h. Now, these formulas are on that last page, or it'll be given to you on the semester exam. Okay, and so the radius is actually half of 6, it's 3. So I get 3 squared, and the height is 8. Now, I'm using this number, so I'm not going to do it in terms of pi. I'm going to find the exact, I'm going to find an approximation by multiplying by pi. And I get 226.19 is the volume of that cup. So if I fill this up to see how many cups of volume 226.19 fit, not on that one, fit inside my 6,912 cubic inch aquarium. So dividing these, I find that it is 30.56, which rounds up to be, I need my 31st cup. To fill up the aquarium. Okay. In number 23, the three-dimensional figure is the result of rotating a two-dimensional figure 360 degrees around a line. Which of the following is the two-dimensional figure that resulted in the cone? Okay, well, how can I get a cone? By rotating things around, and hopefully you can just see visually that's A. If I rotate this around, then I get that, and I get this, and it gets a cone. Okay, the others will be other kinds of shapes, but this one is the cone that's pictured above. 24, two cylinders, each with a height of 15 centimeters are shown. Which of the following is correctly completes the statement? If x is less than y, so if this length here is less than y, so let's just put some numbers in here. If this is 2 and this is 3, for example, okay? Then the volume of cylinder A, how does that compare to the volume of cylinder B? Well, I'm going to look at some cross sections. If I look at this cross section here, this is still 2 and this is still 3. And that in that cross section, cylinder A, sorry, this circle is less than this one. And at this cross-sectional height, this is still 2 and this is still 3, that this cylinder A's cross-section is less than cylinder B's cross-section. And so if at every cross-section, as you go up and down, every single cross-section of cylinder A is less than the cross-section of cylinder B, then as you add them all up, cylinder A will be less than the volume of cylinder B. Okay, it is the same as this sign right here, but it has to do with cross-sections and Calavari's principle. Emma buys a block of clay for an art project. The block is shaped like a cube, as shown in the figure. A cube with edges lengths of 12 inches. She decides to cut the block of clay in 2 pieces. She places a wire across the diagonal of each face of the cube as shown in the figure. She then pulls the wire straight back to cut 2 congruent chunks of clay. So she pulls it back here and pulls it back here, and it comes out of the block back here. Okay, now 25, what is the shape and area of the 2-dimensional cross-section near a square inch? So this, what is this area right here? Well, I know this length right here is 12. That's pretty easy. I don't know how long this is. Whoops. How long this is. But I can find it. So it's a cube, and so if this is 12, this is also 12. And if it's a cube, then I have a right angle. And I can use the Pythagorean theorem to find that length. So the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So c squared is x squared. A and b are both 12. 12 squared is 144. 12 squared is 144 equals x squared. 144 plus 144 is 288. Is equal to x squared. So x is equal to the square root of 288, which is approximately 16.97 inches long. Okay, so this shape right here, this length here is 16.97, and this length is 12. And if you can picture it within the rectangle, you actually would get right angles here. It's kind of hard to kind of prove that in an easy way, but it does end up being right angles. And so you get a rectangle. Okay, that's the shape. And the area is, oh, I didn't find the area yet. Whoops, it's a rectangle. The area is base times height, which is 16.97 times 12. And that is 203. Now, to the nearest whole square inch is about, also approximately 204 square inches. So it's a rectangle. The area is about 204 square inches. Okay. Now, some of the confusion has happened in that students are trying to use this 204 number in 26, and actually you have to kind of brain dump 25 before you do 26. So I will not use anything I did for 25, except the fact that I cut it in half. So I'm kind of going to just even go back to basics here. Cut that in half. I've now cut it in half, right? So I'm looking at kind of half of the chunk, half of the cube. Now, the easiest way to get that, you could think of it like a triangular prism and work your way through that, but honestly, it's half a cube. Cubes are pretty easy because the base is a square, 12 times 12, okay, which is 144, and the height is 12, and so I get 144 times 12. This is the full cube. So 12 cubed is 1728. That's too much, right? So Emma cuts it in half. So I will cut the volume in half as well. Cut the volume in half, divided by 2, and I get 864 cubic inches. That's the volume of this kind of half chunk of clay. All right, so she wants to make spheres that have a diameter of 3 inches. Okay, now the volume of a sphere is 4/3 pi r cubed. That formula is given to you again with that reference material that you'll have on the exam, but you have to know how to use it. 4/3 pi. The radius is not going to be 3. That's a diameter. The radius will be 1.5 cubed, not squared, cubed. Okay, so plugging that in, we have 4/3 pi times 1.5 cubed, and I get each sphere has a volume of 14.137. Okay, so how many of those spheres fit inside of my half chunk of clay? I will divide this by 14.137. And I get 61. It's approximately 61.11. I'll just leave it at 61.1, okay? But I can't make the 62nd, and so I get 61 spheres. Okay? So, those are two problems are kind of involved. Number 27, the Luxor Hotel in Las Vegas is the shape of a square pyramid. So here's a square pyramid. If I can get that just right. Anyway, square pyramid. Okay, similar to the pyramid of Caffrey. I'm not sure how to say that. The Luxor Hotel has a base length of 550 and a height of 350. Okay, the pyramid of Caffrey has a base length of 706 feet and a height of, let me just draw this out too, so it's a little bit bigger. Okay, has a base length of 706 and a height of 448. Okay, what is the difference between the volume of the pyramid of Caffrey and the pyramid of the Luxor Hotel in cubic feet? Well, I got to find both volumes and then subtract them. So I'll start with Luxor Hotel. The volume formula is 1/3 the area of the base times the height. Okay. Now the most important piece of this that most students miss is this area of the base. Okay, the area of the base is not 550. Okay, it's a square pyramid, so it's 550 by 550. Okay, and 550 times 550 is 302,500. So 302,500. And the height is 350. So 1/3 of the 302,500 times 350 is a very big number. It's this big number. Oops. Okay. 1, 2, 3, 1, 2, 3. So 35,291,666.6 repeating is the approximate volume of the Luxor Hotel. Okay. The pyramid of Caffrey is very similar. I'll just make this one green. Where I have the volume is 1/3 the area of the base times the height. Again, the base is not 706, but it's a square that's 706 by 706. So 706 times 706, so I get 1/3 of this number, 498,436, or 400, that's a common on decimal, 498,436 square feet, and the height is 448. So if I multiply 1/3 times this number, 498,436, times 448, then I get this big number, which is 74433,109.3 repeating, looks like. Okay, which, looking at place value, so 74,433,109.3 repeating. Now, the difference the difference between those, I'll do big minus small, so the big one minus the small one. And the difference I get here, is this number, 39,141,442.6 repeating, and the units are feet, so it's in cubic feet, and that's the difference. Okay, those are the 27 problems that are like the ones on the semester exam. Again, I'll show you that I will give you this reference sheet on the semester exam. Okay, but hopefully this video was helpful to you. If you've gotten this far, welcome. Be prepared that watching this video alone will not be enough to do well on the exam. Okay, do your best without using this video, without using the answer key. Then use the answer key or this video to help check or better understand the material, and then try it again. Okay, and then find other reviews. You have access to lots of things on Google Classroom, other materials, and so trying new problems fresh is the best way to study for any exam in any class. Okay, well, thanks for watching this far. Hopefully this video was helpful. I hope you do well on the exam. Thanks for watching.